The sky didn't look any different that night. No fire, no warning, no bright streak cutting across the stars, just a quiet screen filled with numbers. Far from city lights, in rooms humming with computers and coffee machines, astronomers did what they always do. They watched. They measured. They logged another moving dot against the black. This one was small, cold, faint. It slid along the ecliptic like thousands of objects before it. They named it 3I/Atlas. At first, it felt routine. Another visitor passing through. Another body obeying gravity. Another line in a database that would soon be forgotten. But something about it refused to stay quiet. Because space has rules, and objects that move through space usually follow them. They spin. They reflect light in predictable ways. They warm as they near the sun. They fade as they drift away. Astronomers have spent decades learning these patterns. They can look at a light curve and tell you what an object is made of, how fast it's spinning, even how old it might be. That's why the first numbers raised eyebrows, not alarms. Not panic. Just confusion. 3I/Atlas was moving exactly where it should be. Its path along the ecliptic made sense. Its speed was clean. Its trajectory smooth. On paper, it looked normal. But when the first brightness data came in, something felt off. The light curve didn't settle. It flickered. Not wildly, not dramatically, just enough to feel wrong. At first, scientists assumed the obvious. Instrument noise, a calibration issue, a bad angle. These things happen all the time. So they waited, they adjusted, they recalculated. They observed again, and the flicker stayed. Every time the object was measured, the numbers drifted just slightly away from expectation. Too bright, then too dim, too steady, then oddly uneven. It wasn't breaking the rules, it was bending them. That's when curiosity replaced routine. More telescopes were brought in. Independent teams across different continents pointed their instruments toward the same faint speck. Different skies, different hardware. Same result. The anomaly followed the object. And that's when silence fell over the rooms. Because in astronomy, coincidence disappears quickly. If one telescope sees something strange, you question the machine. If every telescope sees the same thing, you question the object. 3I/Atlas didn't behave like debris. It didn't behave like ice. It didn't behave like rock. As it moved closer toward the sun, nearing its slow journey toward perihelion, it should have brightened in a smooth curve. Instead, it hesitated, like it was deciding how bright it wanted to be. That thought made people uncomfortable. Not because it suggested anything impossible, but because it suggested intention. And intention doesn't belong to cold space. In meetings, scientists chose their words carefully. They said things like irregular. They said unmodeled behavior. They said data uncertainty. But behind those careful phrases was a shared feeling no chart could erase. This object was not behaving passively. Every model they ran almost worked, but never fully fit. Change the rotation speed, and something else broke. Adjust the shape, and the thermal readings failed. Assume a dusty surface, and the reflectivity refused to match. 3I/Atlas didn't want to sit inside a box. It slipped out of every explanation by just a little, and that little mattered, because astronomy is a science of distance and patience. When something stands out this early, this far away, it usually means the story is only beginning. Some researchers remembered older anomalies. Objects, once thought natural, later found to be something else entirely. History has a way of humbling certainty. Still, no one said the dangerous word out loud. Not yet. Instead, they watched. Night after night, the data came in, and the object kept doing the same quiet thing. It drifted, it reflected light, and it refused to behave exactly like it should. The numbers didn't scream. They whispered, and whispers are harder to ignore, because whispers suggest intention. At some point, one astronomer asked a simple question during a routine briefing. If this is normal, why does it feel like it's reacting? The room didn't answer. Screens glowed softly. Graphs hovered mid-air. Lines rose and fell. No one laughed. No one dismissed it, because everyone had felt it too. This wasn't fear, it was recognition. The sense you get when something familiar suddenly feels unfamiliar, even though nothing obvious has changed. 3IATLAS wasn't announcing itself. It wasn't sending messages. It wasn't glowing or accelerating or breaking physics. It was doing something far more unsettling. It was almost normal. And in science, almost is where discoveries hide. As the object continued its quiet approach, teams began logging its behavior with more care, more precision, more attention to timing. Every observation mattered now. Every photon counted, because whatever this was, it had already crossed an invisible line. It had moved from background noise to focus, and once something has your focus, it's hard to look away. Some nights the data felt calm, reassuring. Other nights, the curves bent just enough to raise old doubts again, like the object was testing boundaries, like it knew when it was being watched. That thought never made it into any report, but it lingered, unspoken. Out there, beyond the orbit of planets, a small visitor moved steadily through the dark. No tail, no roar, no warning, just a faint pulse of reflected light, telling scientists one thing very clearly. This was not going to be simple. And as 3I/Atlas continued toward the sun, carrying its unknown origin with it, one quiet truth settled into the minds of those watching. Discovery doesn't always arrive with shock. Sometimes it arrives as a question that refuses to go away. And the question hanging over 3I/Atlas was simple. If this is just another object drifting through space, why does its data already feel like it's watching us back? And that question was only the beginning. The closer it moved, the less it made sense. At first, the change was subtle, easy to ignore. Just another line on a graph that didn't quite settle where it should. But as 3I/Atlas drifted closer to the sun, nearing perihelion, the light curve began to misbehave. And this time, no one could look away. In astronomy, brightness is a language. It tells you how fast an object spins, what its surface is made of, whether it's shedding dust or cracking ice, or slowly dying under heat. For decades, scientists have learned to read this language fluently. They've seen comets flare as sunlight hits frozen gas. They've seen asteroids blink as they rotate. They've seen chaos, and they've seen order. But what they were seeing now didn't speak any known dialect. 3I/Atlas brightened, then dimmed, then brightened again. Not smoothly, not randomly. It pulsed, and not in a way that fit rotation. If the object was spinning, the light curve would repeat at a steady rhythm. But this rhythm drifted. It sped up, then slowed down, then paused, just long enough to feel intentional. Scientists tried the simplest explanation first: dust. Maybe jets of dust were bursting from the surface, scattering sunlight unevenly. But dust signatures leave fingerprints, and 3I/Atlas left none. Then they tried ice. As ice heats, it sublimates. Gas escapes, brightness spikes. But ice reacts to sunlight gradually. This object didn't. Its brightness rose sharply, then cut off, like a switch being flipped. Rotation models came next. Change the shape, change the spin, stretch it, flatten it, tilt it. Nothing worked. No matter how they adjusted the math, the curve refused to settle. It wasn't chaotic enough to be natural, and it wasn't clean enough to be mechanical. It lived in an uncomfortable space between. That's when the phrase "broken light curve" began circulating quietly. Not in papers, not in public releases, just between people who knew what a normal curve looked like and could feel when one was wrong. As perihelion approached, the sun grew stronger. Heat increased. Radiation intensified. This should have simplified the behavior. Instead, it made things worse. The pulses became clearer, sharper, almost deliberate. Across observatories, the same pattern appeared. Different instruments, different wavelengths, same timing. That detail mattered, because coincidence fades quickly when timing lines up. What unsettled scientists most wasn't the change itself, it was the control. 3I/Atlas didn't flare wildly under solar stress. It didn't shed mass uncontrollably. It didn't spin out of stability. It regulated. When brightness rose too fast, it stopped. When it dimmed too much, it corrected. The light curve didn't spiral into chaos. It hovered, balanced on a thin edge. And balance is rare in space, especially near the sun. Some researchers began asking uncomfortable questions. Could the surface be layered? Could it be reflective plating? Could internal structure be affecting output? Every idea added complexity, but removed simplicity. And simplicity is what natural objects usually have. At this point, the word anomaly was unavoidable. Still, no one jumped to conclusions. Science moves slowly for a reason. Extraordinary claims demand extraordinary proof, so they hunted for mistakes. They double-checked timestamps, recalibrated sensors, cross-referenced historical data. They searched for anything that could explain the broken curve. And yet, the anomaly stayed. Night after night, the object crossed the same starfields, its position predictable, its brightness not. There were moments when the curve almost normalized, just long enough to create hope. Then it would slip again, like it was aware of expectations and quietly refusing them. That thought never made it into official notes, but it lingered. Because humans are pattern seekers, and this pattern was asking to be noticed. The deeper scientists looked, the stranger it became. The pulses weren't random in time. They clustered, then spread, then clustered again. Like breathing. Not fast. Not slow. Measured. Controlled. That comparison made people uneasy. Breathing implies life, and no one was ready for that idea. So they stepped back. They reminded themselves, light curves can deceive, Instruments can lie. Models can fail. But reality eventually reveals itself. Yet reality wasn't clarifying. It was thickening. By now, 3IATLAS had the full attention of the community. Not because it was dramatic, but because it was subtle. Subtlety is harder to dismiss. Anyone can spot an explosion. It takes experience to recognize restraint. As the object reached its closest approach to the sun, something else happened. The brightness stabilized. Briefly, perfectly. For a short window, the curve flattened, as if the object had found an ideal state. Then, just as suddenly, it broke again. That moment became a turning point, because natural objects don't find equilibrium. They fall into it or miss it entirely. This felt different. This felt chosen. Still, no signal was detected. No radio burst. No transmission. No message. Just light. Just reflection. Just a curve that refused to behave. And that raised the most haunting possibility of all. What if the light curve wasn't broken? What if it was complete? What if the mistake wasn't the data, but our expectation of what normal looks like? As 3I/Atlas continued its silent passage, one truth settled in. This was no longer a question of observation. It was a question of interpretation. Were scientists witnessing noise, or were they witnessing structure they hadn't learned to read yet? Because if the curve wasn't random, if it wasn't natural, then it wasn't just light they were seeing. It was behavior, and behavior implies purpose. The broken light curve didn't scream for attention. It whispered, patiently, and the closer the object came to the sun, the clearer that whisper became. Something was wrong, or something was new, and the difference between those two ideas was about to change everything. At first, no one wanted to say it out loud, because saying it would change everything. The data had already caused enough tension, enough late nights, enough quiet arguments in rooms filled with glowing screens. So when the pattern first appeared, it was treated like a mistake, a rounding error, a timing glitch, a coincidence too small to matter. But coincidence doesn't survive scrutiny, and this pattern survived everything. When scientists went back through the reflected light data, hours, days, weeks of measurements, they noticed something strange hiding beneath the noise. A pulse. Not strong, not obvious, just a gentle rise, then fall repeating. At first glance, it looked like random fluctuation. The kind you expect when you're measuring faint light from something millions of miles away. But then, someone did something simple. They lined up the data from different observatories, different continents, different telescopes, different teams who had never spoken to each other. And the pulse lined up perfectly. Same timing, same spacing, same rhythm. That's when the room went quiet. Because random noise doesn't synchronize itself across the planet. Noise is messy, uncoordinated, wildly inconsistent. This wasn't. This was steady. The pulse appeared in optical light first, then infrared, then again, faintly, in reflected solar wavelengths. Everywhere they looked, the same gentle beat appeared. Like a heartbeat buried deep under static. The obvious explanations came fast. Rotation? Already ruled out. Surface jets? No dust signature. Solar interference. The timing didn't match solar activity. Instrument bias? Different hardware saw the same thing. Every explanation collapsed under the same weight. The pulse kept time. That detail mattered more than anyone expected, because timekeeping is hard, even for humans. We build machines just to keep time, and they still drift. But 3I/Atlas, a silent object tumbling through space, was doing it naturally. Or so it seemed. The pulse wasn't fast. It wasn't slow. It was deliberate, measured in clean intervals, not exact like a digital clock, but consistent enough to feel intentional, like something counting without numbers. Scientists ran simulations. They injected artificial noise into models, tried to recreate the pattern accidentally. They couldn't. The probability was too low. The alignment too clean. This wasn't randomness clustering by chance. This was structure, and structure changes the conversation. Suddenly, people weren't asking what the object was made of. They were asking how it behaved. And behavior implies rules. Rules imply design. That line of thinking made people deeply uncomfortable. Because no one wanted to jump ahead. No one wanted to be the person who saw faces in clouds or messages in static. So they slowed down. They stared harder. They tested timing. They zoomed in on the pulse itself. And that's when they noticed something else. The pulse wasn't constant. It adjusted. When observation frequency increased, the pulse softened. When fewer eyes were watching, it sharpened, not dramatically, just enough to feel reactive. That detail never made it into a paper, but it spread, quietly, like all unsettling truths do. How does it know when it's being observed? That question wasn't meant literally. But once spoken, it didn't leave. The object wasn't sending radio waves. It wasn't broadcasting messages. It wasn't responding to signals. It was just reflecting light. And yet that light behaved like it was organized, time-aware, as if the object carried an internal rhythm, a clock without hands. That idea challenged something fundamental. In space, timekeeping usually comes from motion. Spin, orbit, decay. But this pulse didn't match any known motion. It existed independently, as if the object carried time inside it. Some compared it to pulsars, but pulsars scream across the cosmos with energy. This was different. This was quiet, subtle, almost polite, like it didn't want to be noticed, but didn't care if it was. As days passed, the pulse became easier to detect. Not stronger, just clearer. Because once you know where to look, pattern reveals itself. And once pattern reveals itself, disbelief begins to crack. People started asking questions they had avoided before. Could this be artificial? Not alien, not intelligent, not alive, just artificial. Constructed, engineered. That word alone was enough to stop conversations mid-sentence. Artificial meant intent, and intent didn't belong here. Not between planets, not drifting along the ecliptic, not hiding behind reflected sunlight. Still, the data didn't care about comfort. It kept repeating. Pulse, pause, pulse. The timing didn't drift with distance. It didn't stretch or compress as expected. It stayed, anchored, like a metronome set long before humans existed, and still ticking. The most haunting part wasn't the pulse itself. It was the silence around it. No sound, no message, no response. Just a rhythm, existing for its own sake. That raised a frightening possibility. What if the pulse wasn't for us? What if it wasn't communication, but maintenance? A system checking itself. A process running quietly in the dark. Machines don't need witnesses. They just need time. And suddenly, the question shifted again. If this was a machine, what was it doing here? And why now? No one had answers, only graphs, only light, only a quiet beat, hidden inside reflected sunlight. The object continued its path, indifferent to the fear growing around it. To 3I/Atlas, nothing had changed. It didn't speed up. It didn't turn. It didn't react dramatically. It just kept time. And that might have been the most unsettling part of all, because life is messy. Natural objects are chaotic. But machines are patient. Machines wait. As the pulse continued, scientists faced a difficult truth. They weren't discovering something new in the sky. They were discovering a limit in their understanding, a place where perception ends and interpretation begins. Was this truly a signal, or was the universe simply reminding us that order can exist without meaning? That question haunted every late-night analysis, every quiet moment staring at the curve. Because if the pulse was intentional, then someone, or something, had learned how to keep time without ever speaking. And if it wasn't intentional, then nature itself was far stranger than anyone had imagined. Either answer was unsettling. And as 3I/Atlas continued its silent journey, one thing became clear. This was no longer just about an object in space. It was about how humans recognize intelligence and whether we even know what we're looking for. The pulse didn't answer questions. It created them. And somewhere in that steady rhythm, the certainty of normal space quietly disappeared, leaving behind a ticking mystery, waiting to be understood. The heat should have told a simple story. It always does. In space, temperature is honest, brutal, unforgiving. Get closer to the sun, and you heat up. Move away, and you cool down. That's the rule. That's how every rock, every comet, every lifeless object has behaved since the beginning of time. So when scientists turned their infrared instruments toward 3I/Atlas, they expected confirmation, something solid, something grounding. Instead, they found another crack. At first, the readings looked normal. The object warmed as sunlight touched its surface. Just as predicted, just as comforting. Then, it didn't. The temperature dropped. Not slowly, not gradually. It dropped fast, too fast, as if the heat had somewhere to go. Infrared cameras captured the shift in real time. One moment warm, the next cooler than models allowed. Scientists blinked, rechecked the feed, adjusted calibration. The numbers stayed. Then, just as suddenly, the temperature rose again, back to where it should be, like nothing had happened. But something had, because objects don't cool themselves in space. They radiate heat slowly, passively, according to physics, written long before humans learned to measure it. 3I/Atlas wasn't following that script. The pattern repeated. Warm, cool, warm again. Not random, not chaotic. Timed. The intervals were precise enough to stand out. That's when the phrase thermal pattern entered the conversation. And with it, unease. As the object moved closer to perihelion, the sun's influence grew stronger. Radiation poured in. Heat should have climbed relentlessly. Instead, the object responded, almost defensively. When the surface temperature rose too quickly, it dropped. When it dipped too low, it corrected. It wasn't reacting. It was regulating. That distinction mattered more than anyone wanted to admit. Reaction is natural. Regulation implies control. Control implies boundaries. And boundaries imply design. Scientists searched for explanations that didn't cross that line. Maybe the surface was layered with unusual materials. Maybe it had pockets of volatile compounds releasing heat unevenly. Maybe internal fractures were venting energy. Every theory sounded reasonable, until the timing ruined it. Natural processes don't keep schedules. They spike, they decay, they wander. But this pattern returned again and again, like it was checking a condition and responding accordingly. The thermal shifts didn't lag behind solar input. They anticipated it. That detail made rooms go quiet, because anticipation requires prediction, and prediction requires awareness of change. No one used that word openly, awareness. Instead, they said feedback mechanism. They said unknown thermal dynamics. They said model mismatch. But everyone understood what was being avoided. The object wasn't heating up and cooling down like a rock. It was behaving like a system. As more infrared data poured in, the picture sharpened. The cooling wasn't uniform. Certain regions shed heat faster than others, then redistributed warmth across the surface. Like circulation. Like internal flow. That idea unsettled people deeply, because circulation belongs to atmospheres, to fluids, to engineered systems, not to silent objects drifting through vacuum. Some compared it to spacecraft heat shields, how satellites redirect thermal energy to survive harsh sunlight. That comparison ended conversations abruptly, because no one wanted to be the first to say it. This wasn't just odd behavior, this was survival behavior. 3I/Atlas wasn't cooking itself near the sun. It wasn't cracking apart. It wasn't shedding mass. It was staying stable, calm, balanced, as if it had done this before, as if perihelion wasn't a threat, but a condition it expected. That thought lingered uncomfortably, because comets fear the sun, machines prepare for it. The timing of the thermal shifts lined up with the light pulses, not perfectly, but closely enough to suggest coordination. Light changes, then temperature correction. Temperature rises. Reflectivity adjusts. Different systems moving together. That's when a quiet realization began to form. This object wasn't a single phenomenon. It was layered. Light behavior, thermal behavior, timing behavior, all intersecting, all controlled. The deeper scientists looked, the more the old explanations collapsed. This wasn't ice sublimating. This wasn't dust scattering. This wasn't rotational shadowing. This was management. And management implies intention, even without intelligence. A thermostat doesn't think, but it acts. It responds to thresholds. And 3I/Atlas was responding. Carefully, deliberately. Still, no energy source was detected. No exhaust, no emissions, no power signature. That made it worse, because it meant the system was efficient, quiet, self-contained, the kind of efficiency engineers dream about and nature rarely achieves by accident. Some researchers began wondering if the object was ancient, older than planets, older than stars in our region, built long ago to endure. That idea had no evidence, but neither did the alternatives, and uncertainty has a way of inviting speculation. As days passed, the thermal pattern stayed consistent. Not perfect, but intentional enough to resist dismissal. It didn't drift. It didn't decay. It persisted. The object wasn't overheating. It wasn't freezing. It was maintaining itself. And that raised the question no one wanted to ask directly. What kind of object manages its own heat? In deep space? Not a rock, not ice, not debris. Only systems care about equilibrium. Only machines protect themselves from extremes. Still, the object never acknowledged the attention. It didn't change course. It didn't increase activity. It didn't escalate. It just continued, calmly, silently, adjusting itself as needed, as if being watched didn't matter, as if this behavior wasn't meant to be hidden or revealed, just maintained. That was perhaps the most unsettling part. If this was artificial, it wasn't reacting to discovery. It wasn't defensive. It wasn't curious. It simply existed, following rules set long ago. And that left scientists with a growing sense of smallness. Because if this object was engineered, then whoever built it didn't care who noticed, or when, or if. As 3I/Atlas moved past its closest point to the sun, the thermal regulation continued flawlessly. No degradation, no failure, no stress response. It passed the ultimate test of heat without effort. And when the sun's influence began to fade, the object didn't relax. It didn't drift back into randomness. It stayed controlled, consistent, balanced. The heat story ended where it began, without resolution. No explanation fit cleanly. No conclusion satisfied everyone. Only one thing was certain. This object was not merely reacting to space. It was negotiating with it. And that realization changed the nature of the mystery. Because anomalies can be dismissed, but systems demand understanding. As the data archives grew thicker and the nights grew quieter, a shared feeling settled in. This wasn't about discovering something strange. It was about confronting something prepared. Prepared for heat. Prepared for time. Prepared for the long dark between stars. And if 3I/Atlas could manage its own temperature, then the next question became unavoidable. What else could it manage? And why had it chosen to pass through our sky? Now? It should have grown brighter. That's the simplest rule of all. As an object moves closer to the sun, light floods its surface. Ice flashes, dust glows. Even dark rock gives something back. Brightness rises. That's what every model says. That's what decades of observation confirm. So when 3I/Atlas began to do the opposite, people froze. Instead of flaring, it dimmed. Not suddenly, not dramatically. Quietly, like it was turning something down. At first, scientists assumed geometry. Maybe the angle was wrong. Maybe shadows were hiding part of the surface. They adjusted for that. The dimming stayed. Then they blamed composition. Maybe it was coated in something unusually dark, carbon-rich, light-absorbing. But even the darkest natural surfaces reflect more light when pushed closer to the sun. 3I/Atlas didn't. As solar radiation intensified, its reflectivity dropped. That detail didn't just break a rule, it reversed it. The surface wasn't scattering more light. It was absorbing it, deliberately. And absorption creates heat, which should have been a problem. Except it wasn't, because the thermal data had already shown something impossible. The object wasn't overheating, it was managing. That's when a new idea emerged. What if the surface wasn't passive? What if it was adaptive? Engineers on Earth build materials that change reflectivity. Satellites do it to survive extreme conditions. Solar panels adjust angles. Heat shields redirect radiation. But those are machines, designed, engineered, purpose-built. 3IATLAS wasn't supposed to be any of those things. Yet the data painted a clear picture. As the sun grew stronger, the object grew darker, reducing how much energy bounced back into space, reducing how much attention it drew, reducing stress. It was doing exactly what you'd want a system to do near a star. The timing was precise. The reflectivity shifts lined up with thermal corrections. Light absorption increased. Temperature stabilized. Light reflection increased. Heat dissipated. Different behaviors moving together. Coordinated. This wasn't erosion. This wasn't surface decay. This was response. And response implies choice. No one liked that word, so they avoided it. They used safer language. Dynamic albedo, variable reflectivity, surface phase transition, words that sound technical but don't answer the question. Why would a natural object evolve a surface that adapts in real time? Evolution requires environment, selection, feedback over millions of years. But nothing evolves in interstellar space. There's no pressure, no competition, no gradual refinement, just cold, dark, silence. And yet here was an object behaving like it had been optimized for one thing: survival near stars. As 3I/Atlas reached peak solar exposure, its reflectivity hit a minimum. It was darker than predicted, darker than comparable bodies, almost as if it was trying not to shine. That detail disturbed people deeply, because brightness is how we notice things. Dimming is how you avoid notice. That thought lingered. Uncomfortable, unspoken. No one suggested intent publicly, but privately, the question surfaced again and again. Why hide? The object didn't need to. It wasn't changing course. It wasn't accelerating away. It wasn't shielding itself from detection entirely. It was just moderating, enough to stay stable, enough to stay quiet, like someone lowering their voice without leaving the room. Some scientists compared it to thermal camouflage. Others dismissed that as imagination, but no one could explain the mechanism. Natural materials don't adjust reflectivity in response to solar intensity with this precision. They degrade. They crack. They fail. 3I/Atlas didn't fail. It adapted. As the days passed, models grew more complex. They began simulating layered surfaces, outer skins that darken under radiation, then lighten again, self-healing coatings, smart materials. Every model that fit felt wrong, because fitting the data meant accepting one uncomfortable truth. This object behaved like it had been designed to pass close to stars without damage. Designed or discovered. That distinction blurred. Some researchers wondered if the object wasn't interstellar debris, but interstellar equipment. Not sent, not aimed. Just moving, doing what it was built to do. Others pushed back hard. There was no proof of construction, no markings, no symmetry visible at scale, no obvious machinery, just behavior. And behavior is slippery. You can explain it away until you can't. The reflectivity shifts weren't dramatic. They didn't scream technology. They whispered function. And function is harder to argue against, especially when it works. As 3I/Atlas began to move away from the sun, something else happened. The reflectivity slowly increased, not all at once, gradually, as solar pressure weakened. As heat became less dangerous, the surface relaxed, like a system leaving high alert mode. That transition sealed it. Because random processes don't relax, they just stop. This didn't stop, it adjusted back, like a dial returning to neutral. That moment left a heavy silence in analysis rooms. Because no one could deny the pattern anymore. This object wasn't just surviving space, it was negotiating with it, choosing how much light to return, choosing how much energy to take in, choosing stability over chaos. And choice changes everything. Can a natural body choose? Physics doesn't choose. It reacts. Systems choose. They evaluate conditions. They respond within limits. That realization didn't bring answers. It brought restraint. Scientists became careful with their language, careful with public statements, careful with leaks. Because once the idea of adaptation enters the story, control is never far behind. Still, no communication emerged. No signal, no message, no acknowledgement. Just a surface that knew when to shine and when not to. That made the silence louder. If this was a machine, it wasn't curious. If it was artificial, it wasn't interested. If it was intelligent, it didn't care. It passed by like a professional, efficient, unemotional, unimpressed. And that left humanity in a strange position, watching something that didn't need us, didn't respond to us, didn't even reflect us fully. Just enough light to be seen, not enough to be understood. As 3I/Atlas continued its journey away from the sun, its reflectivity settled into a stable state. The anomaly didn't vanish. It completed its cycle, like a test finished successfully, leaving behind a trail of data and unease. Because if an object can control how bright it appears, then brightness is no longer just a property, it's a decision. And once that door opens, it never closes again. The question lingered in every mind. If this object chose how much light to return, what else was it choosing not to show us? And, more importantly, what had it already learned about the star it just passed? Because stars reveal more than heat. They reveal intention. And 3I/Atlas had just proven one thing beyond doubt. Whatever it was, it understood the sun. And it survived, quietly, on purpose, leaving us to wonder, were we observing a strange object? Or were we witnessing the behavior of something that had done this many times before? And if so, how many other stars had it learned to hide from before ours? It didn't fade away. It didn't drift slowly into noise. It stopped. One moment, the pulse was there, steady, familiar now, almost expected. And then, nothing. The light curve smoothed out. The sharp rises and falls softened into a clean, ordinary line. The small irregularities that had kept scientists awake for weeks simply vanished. No warning, no transition, no explanation. Just silence. At first, no one trusted it. They assumed a failure, a missed update, a gap in coverage. Someone rechecked the timestamps. Someone else refreshed the feed. The data held, 3I/Atlas, was still there, still moving, still reflecting sunlight. But the pulse was gone. It felt wrong, because patterns don't just disappear. Not without a reason. Scientists compared old and new graphs side by side, before and after. Pulse and calm. The difference was unmistakable. What had once looked alive with structure now looked boring, normal, and that scared people more than the anomaly ever had. Because chaos fading into order is expected, order fading into emptiness is not. Across observatories, the same result appeared. No pulse, no timing structure, no rhythm hiding in the noise, just smooth, predictable behavior, as if the object had decided it was done. Some thought this was relief. Finally, a return to comfort. A chance to close the books and say it was all a misunderstanding. But relief didn't come. Instead, unease deepened. Because the silence felt intentional. The pulses hadn't weakened gradually. They hadn't drifted out of phase. They hadn't decayed. They had shut off, like a switch being flipped. That detail mattered. Natural signals fade. Machines stop. People began whispering again. Not about what the object was, but about why it had changed. Had the pulse only existed under certain conditions? Heat? Observation density? Solar angle? They searched desperately for a trigger, and then they noticed something subtle. The pulses stopped shortly after observation intensity peaked, when more eyes than ever were focused on the object, when analysis went public, when internal debates spilled into wider circles, when attention reached a tipping point. That timing made everyone uncomfortable, because it suggested awareness, not intelligence, not consciousness, just responsiveness. As if the object had crossed some internal threshold and adjusted. The phrase observer effect came up more than once, usually as a joke. No one laughed. The object didn't change its path. It didn't accelerate. It didn't deploy anything new. It simply became quiet. And quiet can mean many things. Some argued the pulse was never real, that it had always been noise, misread through expectation. But that argument collapsed under old data. The pulse was there, measurable, repeatable, verified across instruments. Its absence was just as real. Others suggested the system had completed a process, a calibration, a check, like a machine booting up, then going idle. That idea hung heavy in the air, because idle systems aren't broken, they're waiting. As days passed, scientists kept watching, waiting for the pulse to return. It didn't. The light curve remained smooth. Predictable, almost disappointingly normal, but the calm felt staged, like the quiet after a loud room empties. Not peaceful. Empty. People who had grown used to the rhythm felt its absence physically. They missed it. Not because they liked it, but because it had become a presence. Something to orient around. Now there was nothing, just silence. That silence raised the hardest question yet. Was the pulse ever meant to be constant, or was it only meant to be noticed once? That idea struck deep, because it implied intention without communication, action without explanation. If the pulse had been a signal, it wasn't one we could respond to. If it was a process, we weren't meant to understand it. If it was camouflage, then the object had just decided it no longer needed it. Some scientists wondered if the pulse was internal, a diagnostic, a system checking itself as it approached perihelion. Once the stress passed, the check ended. That explanation made sense, and that was the problem. It made too much sense, because it framed the object as something that monitors itself. And systems that monitor themselves are not accidents. The silence forced everyone to confront a strange emotional truth. The anomaly had felt like discovery. The silence felt like loss, not because something had gone wrong, but because something had moved on. 3IATLAS wasn't reacting anymore. It wasn't adjusting. It wasn't showing its inner workings. It had returned to baseline behavior. Like a professional who finishes a task and walks away without a word. That metaphor unsettled people deeply, because it placed humanity in an unfamiliar role. We weren't explorers. We weren't discoverers. We were witnesses. Late at night, some scientists rewatched the old data, the pulses, the timing, the strange beauty of the pattern. They wondered if that moment would ever repeat, if anyone else, anywhere else, had ever seen it, or if it was unique to this passage, to this sun, to this brief window of time. That thought carried weight, because if the pulse was situational, then the universe might be filled with quiet systems, revealing themselves only under specific conditions, passing through stars, testing environments, then returning to silence, never announcing themselves, never explaining, just doing what they were built to do. The object didn't care that humans noticed. It didn't react with fear. It didn't escalate. It didn't defend itself. It simply stopped showing us anything extra. That restraint felt deliberate. As days turned into weeks, attention shifted. The public grew bored. Headlines softened. Speculation faded. But inside scientific circles, something had changed permanently. Because silence had become data. The absence of the pulse was now part of the pattern, and absence can be just as meaningful as presence. 3IATLAS continued on its path, slowly drifting away from the inner system, its behavior stable, its surface calm, its light curve smooth. If someone had only started observing it now, they would see nothing unusual, and that realization stung, because it meant the anomaly had been temporary, conditional. A fleeting glimpse into something deeper, now hidden again. That raised a final, haunting possibility. What if the object never intended to communicate? What if the pulse wasn't for us at all? What if we had simply stumbled across a private process and mistaken it for a signal? Like overhearing a machine hum and thinking it was speaking. That idea stripped away comfort. Because it meant meaning wasn't guaranteed. Not everything strange is meant to be understood. Some things exist, regardless of observers. As 3IATLAS faded into distance, one question lingered, heavier than all the others. If the signal stopped because the conditions changed, then what conditions would make it start again? Another star? Another observation density? Another kind of watcher? Or had we already seen everything we were ever meant to see? The silence offered no answers, only a smooth curve and a fading dot. But silence, once noticed, is never empty. It echoes. And somewhere deep in the data archives, the old pulse still exists, waiting. A reminder that something once broke the rules and then chose to stop, leaving behind a quiet warning. Not everything that reveals itself intends to stay revealed. And sometimes the most important moment in discovery is the moment when the universe decides to go quiet again. Because silence can mean many things, but one meaning is impossible to ignore. Whatever 3I/Atlas was doing, it had finished, at least for now. And whether that silence was an ending or preparation for something yet to come was a question no one could answer. Only wait and listen. There's a moment in every investigation when the questions stop being public. Not because the answers are close, but because the ideas become dangerous. That moment arrived quietly. No announcement, no headline, just a shift in tone behind closed doors. With the pulse gone, with the light curve calm, with the thermal behavior logged and verified, scientists were left with something heavier than data. They were left with implications. So they did what scientists always do when the known world stops making sense. They closed the door, and they began testing ideas they would never say out loud. The first rule was simple: assume nothing is impossible. That alone felt wrong, because science is built on limits, on boundaries, on the comfort of probability. But 3I/Atlas had already stepped outside those comforts, so the conversations changed. They stopped asking, "What is it made of?" They started asking something else. What if it was made on purpose? The room always went quiet after that question. Not because it sounded ridiculous, but because it didn't. The idea of an artificial origin wasn't introduced with excitement. It came with hesitation, with disclaimers, with nervous laughter, with phrases like hypothetically and purely for modeling purposes. No one wanted to be remembered as the person who crossed that line too quickly, but someone had to cross it. So they began gently. Could the object have internal structure, not visible at scale, but layered, reinforced, engineered to distribute stress? Models were built, and some of them worked. Could the thermal regulation be the result of artificial shielding? A shell designed to redirect heat, absorb radiation, survive close stellar passes. More models, more uncomfortable results. Could the adaptive reflectivity be a surface coating? Smart material, responsive to radiation intensity. Something that changes state, not randomly, but predictably. Again, the math didn't fail. That was the problem. Each idea fit one part of the behavior, but never all of it. No single theory explained everything. But none of them could be ruled out either. That limbo was terrifying, because science thrives on elimination. Here, elimination refused to happen. Someone brought up the word machine. Not intelligence, not alien life. Just machine, a construct, a thing built to function, without thought, without curiosity. That distinction mattered. Machines don't need to speak. They don't need to explore. They just do what they're designed to do. That idea fit the silence perfectly. 3I/Atlas wasn't curious about us. It didn't react emotionally. It didn't escalate when noticed. It didn't hide completely. It behaved like something indifferent. And indifference can be a sign of design. Some compared it to ancient probes humanity has already launched. Voyager, Pioneer. Objects drifting through space, long after their creators stopped listening. Silent, purposeful once. now just moving. That comparison was chilling, because those probes were never meant to be found. They were meant to endure. Suddenly, endurance became a key word. Everything about 3I/Atlas suggested endurance. Heat management, reflectivity control, structural stability, no visible degradation. This wasn't something passing through once. It looked like something that had done this before, many times. That raised the hardest question of all. If it wasn't natural, who built it and when? That's where the theories fractured. Some imagined an ancient civilization, not advanced in the way movies portray, but patient, a species that built machines to wander between stars, quietly, slowly, collecting nothing, saying nothing. Others suggested something even stranger, that it wasn't sent at all, that it was discarded, left behind, a relic, a forgotten tool, drifting endlessly. That idea carried a strange sadness, because it meant intelligence could exist and vanish without ever announcing itself. Others pushed back hard. They argued, nature can still surprise us, that the universe has complexity beyond our models, that labeling something artificial too quickly is how science loses humility. They were right, and still the behavior remained. No one could explain why a natural object would evolve such layered, coordinated responses in the emptiness between stars. Evolution needs pressure. Space offers none, and that left one unsettling possibility standing longer than anyone liked. Intentional design. Not purposeful toward us, just purposeful. That idea didn't feel triumphant. It felt heavy, because if something built this, then we weren't alone in the timeline of intelligence. We were just late. The discussions grew more careful. Language became precise. No one wrote alien. No one wrote probe. They wrote non-natural hypothesis. They wrote artificiality spectrum. They wrote unknown origin with engineered characteristics. Words designed to protect reputations, while still acknowledging the truth. No theory fit perfectly, but that was the point. Complex systems rarely reveal their full purpose to observers who see only fragments. We see behavior, we guess intent, we fill the gaps with fear or wonder. And humans are very good at both. One scientist posed a question that ended the debate for the night. What if it isn't here for discovery at all? The room fell silent, because that question reframed everything. What if 3I/Atlas wasn't exploring? What if it wasn't observing us? What if it wasn't even aware of us? What if it was simply passing through, following rules written long before humans learned to look up? A machine doesn't care who watches. It doesn't announce itself. It doesn't explain. It just functions. That idea stripped away drama and replaced it with something colder. Meaninglessness. Not everything exists for us. And that might be the hardest truth science ever faces. As days passed, the theories remained locked behind closed doors. No consensus formed. No conclusion emerged. Just a growing list of ideas, each incomplete, each unsettling. Natural explanations felt stretched. Artificial ones felt premature. The truth hovered somewhere in between, unreachable, and that's where it stayed, because admitting uncertainty is safer than choosing the wrong certainty. 3I/Atlas continued drifting outward, unchanged, unaffected, unimpressed by the debates it had sparked. Whatever it was, it didn't need validation. It didn't need belief. It simply existed. And existence, without explanation, can be terrifying. The final question lingered long after the meetings ended. If it isn't natural, who or what made it? No answer followed, only a deeper silence, and perhaps that silence was the answer. Because builders who leave no message, and machines that never speak, might not be hiding. They might just not care whether they're understood at all. And that realization marked a turning point, because from this moment on, the mystery of 3I/Atlas was no longer just scientific. It was philosophical. If intelligence can exist, build, and vanish without ever announcing itself, then what does that say about our place in the universe? Are we observers? Are we late arrivals? Or are we simply another quiet moment in a much older story, still unfolding in silence? That question didn't end the discussion. It opened something deeper. And the deeper scientists looked, the less human the universe began to feel. The data was never supposed to leave the room. Graphs, timelines, notes written in careful language meant only for experts. But information has a way of slipping through cracks, and once it does, it doesn't come back. It started quietly. A screenshot here, a clipped chart there, a phrase taken out of context and shared without explanation. Most people didn't understand it at first, but they felt it. Because you don't need to read data to sense uncertainty. You just need to notice when the people who usually sound confident stop sounding sure. Within days, fragments of the story spread. Not headlines, not breaking news, just questions. Why did the light curve change? Why did the pulse stop? Why did scientists stop speaking clearly? The silence spoke louder than any announcement. Online forums lit up. Amateur astronomers pulled out old telescopes. People who had never cared about space suddenly stared at the sky like it was different, because it felt different. Nothing up there had changed, but perception had. For centuries, the night sky had been a place of comfort, fixed, distant, safe in its indifference. Stars rose and set. Planets followed paths. The universe obeyed rules, even if we didn't fully understand them. Now, that certainty wavered. People began asking questions that had nothing to do with data. What did they see? Why won't they explain it? Are they hiding something or protecting us? Trust, once shaken, doesn't collapse all at once. It shifts, slowly, like tectonic plates under the surface. News outlets debated responsibly at first. Then speculation crept in. Then fear. Then wonder. Some dismissed it as another overblown story. Another mystery that would fade once experts stepped in. Others leaned forward, listened harder, because something about this felt different. There was no explosion, no threat, no invasion, just doubt. And doubt changes people. For some, it sparked curiosity. They learned words they had never heard before. Light curve, reflectivity, perihelion. They watched videos, read threads, tried to understand. For others, it triggered anxiety. If scientists weren't sure anymore, who was? The idea that something could pass through our system, behave strangely, and leave without explanation unsettled a deep human instinct. The instinct to believe we know what's above us. Late at night, people looked up at familiar constellations and felt something new. Distance. Not physical distance. Emotional distance. The sky felt less like a ceiling and more like a door. Parents noticed it in their children, questions that had never come up before. Could something be watching us? Are we alone, or just not important? Those questions didn't come from fear. They came from awakening. The slow realization that certainty is fragile. Scientists tried to calm the conversation. They released statements, careful ones, measured ones. They emphasized uncertainty, called for patience, explained that anomalies don't equal conclusions, but the tone had changed, and people could hear it. The confidence was gone, replaced by caution. And caution feels like secrecy, even when it isn't. Public trust doesn't collapse because of lies. It collapses because of hesitation, and hesitation was everywhere. Some people laughed it off. They joked about alien probes and sci-fi movies. Humor is a defense. Others turned inward. They questioned what else we might be wrong about. If something as basic as objects get brighter near the sun could be challenged, what else had we taken for granted? Philosophers entered the conversation. So did theologians, not to claim answers, but to respond to the shift. Because the reaction wasn't scientific, it was human. For the first time in a long while, people weren't asking, what does this mean for technology? They were asking, what does this mean for us? The idea that discovery could happen without explanation was unsettling. It suggested that knowledge isn't always followed by clarity. Sometimes it's followed by silence, and silence invites interpretation. Some felt small, insignificant, like insects noticing a shadow pass overhead without ever understanding what cast it. Others felt energized, inspired. If the universe could still surprise us, then mystery was alive, and mystery gives meaning. The divide grew quietly, not between believers and skeptics, but between those who needed certainty and those who could live without it. Social media amplified everything. Fear traveled faster than nuance. Wonder traveled faster than evidence. But beneath the noise, something genuine was happening. People were waking up to a truth science had always known, but rarely had to share. We don't control discovery, and discovery doesn't care how ready we are. 3IATLAS didn't threaten Earth. It didn't change orbit. It didn't interact with us at all. And yet, it changed something fundamental. It made people realize how little it takes to shake a worldview. Just a pattern, just a pause, just a silence. People began to question the idea of cosmic comfort, the belief that space is empty, lifeless, predictable. Even those who rejected artificial explanations felt the shift. Because even if 3I/Atlas was natural, then nature itself was stranger than expected, more complex, more layered, less forgiving. That alone was enough to disturb the old calm. Astronomy clubs saw record attendance, so did philosophy lectures. People wanted context, perspective, something to hold on to, but no one could offer certainty, only honesty. And honesty can feel cold. Late-night radio shows took calls from listeners staring at the sky. They didn't ask technical questions. They asked emotional ones. Should we be afraid? Does this change anything? Are we still safe? The answer, always, was the same. We don't know. And "we don't know" is a powerful sentence. It strips away illusion. It invites humility. But it also opens the door to fear or growth. The sky didn't answer back. Stars burned as they always had. Planets followed their paths. The universe remained silent. But the relationship had changed. Humanity had taken a small step out of innocence. Not because something attacked, not because something spoke, but because something behaved and then stopped. That was enough. Discovery had turned into awakening. Not the dramatic kind, the quiet kind, the kind that settles into the back of the mind and never quite leaves. People still lived their lives, went to work, made dinner, watched shows, but sometimes they paused, looked up, and felt a new question forming. Not what's out there, but what if we're not the center of attention? That question doesn't frighten everyone, but it humbles almost everyone. As days passed, the stories slowly faded from headlines. New crises took over. New distractions arrived, but something remained, a subtle shift in how people saw the night. The sky was no longer just a backdrop. It was an unknown that had briefly leaned closer and then pulled away, leaving behind a feeling that couldn't be named. Was it fear, wonder, loss, or growth? No one could agree, but everyone felt it. Because awakenings don't announce themselves. They linger. They change how certainty feels. They teach you that comfort and truth are not the same thing. And once that lesson is learned, you never quite look at the same sky again. The question echoed quietly across millions of minds. What happens when discovery becomes an awakening? The answer wasn't written in data. It was written in perception. And perception, once changed, can never fully return to what it was before. The sky hadn't changed, but humanity had. Just a little, enough to matter. Enough to listen more carefully the next time the universe decides to whisper. Or fall silent again. At first, it looked like nothing. Just noise, static, layered over silence, random variations stacked on top of uncertainty, the kind of mess scientists expect when they push instruments to their limits. But someone kept staring at it, not the headline data, not the smooth curve everyone else had accepted, the mess underneath, and that's where the pattern was hiding. It began as a quiet suspicion. What if the noise wasn't noise at all? What if it was covering something structured? So they stripped the data down again, removed assumptions, removed smoothing, removed what they expected to see. And slowly, something emerged. Not a signal, not a message, a structure, intervals buried beneath the surface, spacing that repeated, not perfectly, not mechanically, but consistently. Too consistent. The timing didn't match any known natural cycle. Not rotation, not orbit, not thermal lag, not solar rhythm. And it didn't match us either. No human clock, no calendar, no algorithm we use. It sat in an uncomfortable middle space. Alien to nature, alien to us, but undeniably there. The object wasn't random. It had never been random. We had just mistaken complexity for chaos. Once the structure was noticed, it became impossible to unsee. The intervals appeared across different datasets, different instruments, different wavelengths. They survived noise reduction. They survived error correction. They survived skepticism. They repeated again and again and again. Not identical, but faithful. Like footsteps from someone walking a familiar path. This wasn't chance clustering. Chance doesn't remember itself. This did. The structure wasn't loud. It didn't announce itself. It wasn't efficient or optimized. It was patient. And patience is not a trait we associate with randomness. Scientists began using a careful phrase: second-order pattern. A pattern beneath the pattern. The kind that only appears when you stop looking for meaning and start looking for behavior. Behavior implies rules. Rules imply boundaries. Boundaries imply intention. That chain of thought made people uneasy, because intention is the line no one wanted to cross. Still, the data refused to cooperate with denial. The intervals drifted slightly over time, but within limits. They adjusted, but didn't break. They adapted, but didn't collapse. This wasn't a rigid system ticking like a clock. It was a flexible one, maintaining consistency while allowing variation. Like a living thing, or a well-designed machine. That comparison split the room. Some argued consistency doesn't equal intelligence. Nature has patterns too. Crystals, waves, fractals. They're beautiful, ordered, repeating, but those patterns scale infinitely. This one didn't. It stopped, started, again, paused, resumed, as if something was deciding when to continue. That decision point was the problem. Because randomness doesn't pause with intention. And nature doesn't usually ask itself when. It simply is. The structure also didn't optimize for observation. It wasn't clear. It wasn't efficient. It didn't repeat in ways easy to detect. Almost like it wasn't meant to be found. Which raised an unsettling thought. What if this wasn't intelligence trying to communicate, but intelligence trying not to? Or something older, something simpler. A system built long ago to do one thing over and over, regardless of who noticed. Some researchers compared it to error-correcting codes, others to heartbeat variability, others to maintenance cycles in long-duration probes. Each comparison fit one angle and failed another. No analogy survived intact. That's when the question changed. They stopped asking, what is it? They started asking, what counts as intelligence? Because intelligence doesn't have to speak. It doesn't have to think like us. It doesn't even have to know we exist. Sometimes intelligence is just consistency applied over time. The ability to maintain function across chaos. 3I/Atlas had crossed interstellar space, endured radiation, endured cold, endured time beyond human scale, and still its behavior held. That alone was remarkable, but the deeper structure suggested more. It suggested planning without planning, a set of rules that didn't drift, a system that remembered itself. And memory is a dangerous word, because memory means past influences future behavior. That's the foundation of learning. No one claimed learning, but no one could rule it out either. The structure beneath the noise didn't care about observers. It didn't change when noticed. It didn't vanish when analyzed. It persisted quietly. Like a heartbeat you only hear when you place your ear against the chest of the universe. Some scientists felt awe, others felt fear. Not fear of invasion or threat, fear of irrelevance. Because if intelligence can exist without curiosity, without communication, without recognition, then humans might not be as central as they've always believed. That idea landed heavily. We're used to intelligence looking outward, exploring, asking, broadcasting. But what if intelligence can also look inward, maintain itself, preserve function, repeat quietly, never announcing its presence, just enduring? That possibility reframed everything. Maybe this wasn't a visitor. Maybe it was infrastructure, not for us, not for this time. Just something that exists, doing what it was built to do. The structure beneath the pattern wasn't dramatic. It didn't inspire movies. It inspired humility. Because it suggested the universe might be full of systems operating on rules we don't recognize, at timescales we don't live on, for purposes that don't include us. As the analysis deepened, one final detail stood out. The consistency didn't degrade. Even as the object moved away, even as energy input dropped, the structure remained intact. That ruled out temporary effects. This wasn't a byproduct of heat. This wasn't stress-induced behavior. This was baseline, the object's default state. That realization settled quietly. If this was the default, then everything we had seen before, the pulses, the adjustments, the anomalies, were not accidents. They were modes. Activated, completed, deactivated. That's not how rocks behave. That's not how debris behaves. That's how systems behave. Still, no message came. No acknowledgement. No proof of awareness. Just consistency. And consistency is a strange thing. Too much of it looks like obsession. Too little looks like chaos. But right in the middle, it looks like intelligence, not human intelligence. Something colder, something older, something content to repeat itself forever. The question lingered. Is consistency the clearest sign of intelligence? Or is that just a human bias? Seeing ourselves in patterns we don't understand? No one could answer that. But everyone felt the weight of it. Because if consistency alone can signal intelligence, then the universe might be filled with minds that never speak, never explore, never care who notices them. They simply exist, repeating themselves across time and distance and stars. 3IATLAS didn't confirm anything. It didn't prove artificial origin. It didn't disprove natural explanation. It did something far more unsettling. It exposed how fragile our definitions are, how much of intelligence we project, and how little we truly understand. As the object faded further into darkness, the hidden structure remained etched in memory, not as evidence, as a question, one that refused to go away. If something can be consistent without being alive, and intelligent without being conscious, then what does intelligence really mean? And how many times has it already passed us by, unnoticed, because it never behaved the way we expected? The pattern beneath the pattern didn't answer that. It simply kept repeating, quietly, faithfully, indifferent to interpretation, leaving us with a final, uncomfortable thought. Maybe intelligence isn't rare. Maybe it's everywhere. And maybe the only reason we don't recognize it dies is because we keep waiting for it to look like us, or speak, or care. And what if the clearest sign of intelligence isn't communication at all? What if it's consistency, maintained across the vast silence of space, long after the builders, if there ever were builders, are gone? That thought lingered, heavy, unresolved, like a rhythm you can't unhear. And somewhere in the darkness beyond our instruments, 3I/Atlas kept going, still consistent, still silent, still doing whatever it was always meant to do, whether anyone understood it or not. Nothing came back, no signal, no reply, no acknowledgement. After everything, the pulses, the patterns, the theories, the universe answered with the one thing humans struggle with most: silence. Scientists watched and waited. They adjusted frequencies. They checked bands that had never been used before. They listened where nothing had ever spoken. Still nothing. 3I/Atlas did not respond. It did not brighten. It did not pulse again. It did not change course. It simply continued. Calm, consistent, unmoved by attention. And that was the moment many people finally understood. If this object was artificial, it was not a messenger. It wasn't here to greet us. It wasn't curious about who was watching. It behaved like something that had never needed an audience. A machine that never speaks. Humanity is used to intelligence being loud. We talk. We signal. We announce ourselves. Our probes carry plaques and messages and hope. We assume intelligence wants to be known. 3I/Atlas challenged that assumption, because whatever it was, it had nothing to say. That realization felt colder than any fear, because silence removes drama. It removes meaning we can hold onto. A threat can be faced, a message can be decoded, but silence offers nothing. Scientists searched for intent anyway. Maybe the object wasn't designed to communicate. Maybe communication wasn't its purpose. Not everything built by intelligence is meant to speak. Bridges don't speak. Satellites don't explain themselves. Infrastructure just functions. 3I/Atlas felt like that, like a piece of something larger. A tool, a system, something built to operate quietly across distances no human mind was meant to fully grasp. The lack of response wasn't defensive. It wasn't hostile. It was indifferent. And indifference is unsettling, because it suggests hierarchy, not in power, but in relevance. We weren't being ignored out of malice. We simply didn't matter to its function. Some scientists argued that silence was proof of nothing, that intelligence would communicate, that awareness seeks connection. They pointed to biology, to evolution, to the drive to interact. Others countered quietly. Biology is local. Engineering is not. Machines don't seek connection. They seek completion. And 3I/Atlas looked like something that had already completed whatever task it was designed for. It passed the sun. It regulated itself. It maintained structure. Then it moved on. No goodbye. No curiosity. No pause. That behavior didn't feel alien. It felt professional. Like a system built long ago, still doing its job. Long after anyone stopped checking in, that idea carried weight. Because humans have already created things like that. We launch machines knowing they may outlive us. We send probes into space with no expectation of return. If one of those probes passed another civilization, would it speak? Would it explain? Or would it just continue, silently? The thought was humbling, because it meant we might be seeing a mirror, not a mystery. 3I/Atlas wasn't reaching out. It wasn't hiding. It was simply existing, according to rules we didn't write. The more scientists listened, the clearer it became. Silence wasn't a failure, it was a feature. Communication requires intent. Silence requires nothing. And nothing about this object suggested a need to communicate. The object never changed behavior when studied, never reacted when debated, never acknowledged attention. It treated humanity the same way it treated empty space. That stung. Not emotionally, existentially. Because humans have built identity around observation, around being seen, around matter responding to us. 3IATLAS didn't respond, and in doing so, it revealed something uncomfortable. The universe does not owe us engagement. Just because we notice something doesn't mean it notices us back. Late at night, some scientists wondered if silence itself was the message. Not a message sent, a message inferred, a demonstration. You can exist without being seen. You can be intelligent without being curious. You can pass through a star system without caring who lives there. That idea stripped away fantasy. No invasion, no revelation. No cosmic conversation, just coexistence, without interaction. And that might be closer to reality than any story we've ever told. The silence also closed doors. Without communication, theories remained theories. Without response, proof stayed out of reach. There would be no confirmation, no satisfying ending. Only data and interpretation. As 3I/Atlas drifted farther away, the chance of interaction faded. No new behavior emerged, no late signal. No surprise, just the steady continuation of whatever process it was running. And that steadiness became its loudest statement, because if it wanted to speak, it could have. If it wanted to react, it would have. The fact that it didn't meant something. It meant that intelligence, if that's what this was, doesn't always care about being known. And that idea quietly changed the question humanity had been asking. Not, are we alone? But, are we important? The silence didn't answer that. It simply forced us to sit with it. Some found peace in that. Others found discomfort, because silence removes the illusion of specialness. It places us back where we've always been, on a small planet, orbiting an average star in a universe that moves on, regardless of who watches. 3I/Atlas didn't threaten that truth. It reminded us of it. As the object continued into deep space, it carried its silence with it, unbroken, unchanged. A moving reminder that not all intelligence seeks connection. Not all machines are messengers. Not all discoveries come with meaning attached. Sometimes the absence of a message is the message. That the universe is vast enough to contain things that don't care who notices them. That intelligence can exist without acknowledgement. That function can outlast creators. And that silence, far from being empty, can be full of implication. The final data streams came in. The object dimmed with distance. The signals weakened. Eventually, 3I/Atlas became just another faint point among millions. Indistinguishable. If someone discovered it tomorrow, without history, it would look ordinary. And that was the most unsettling part. Whatever it was, it blended back into the background effortlessly. like it had never wanted to stand out in the first place, leaving behind a question no signal could answer. Is silence itself the message? Or is it simply the natural state of a universe that never promised to explain itself? No conclusion arrived, only acceptance. And as humanity looked out into the dark, one quiet truth settled in. If something can pass through our world, behave with purpose, and never speak, then the universe may be filled with stories we'll never hear. Not because they're hidden, but because they were never meant to be told at all. It didn't end with a revelation, no final graph, no last-minute signal, no sentence that tied everything together. 3I/Atlas just kept going. Day by day, it moved farther from the sun, farther from our instruments, farther from certainty. The data streams grew thinner, weaker, harder to read. Not because something was being hidden, but because distance always wins. Eventually, the object crossed a quiet line, an invisible boundary where observation becomes memory, where discovery turns into history, and that's where the truth remained, unanswered. Scientists sat with everything they had gathered: light curves that once pulsed, thermal patterns that regulated themselves, reflectivity that chose when to shine, intervals that repeated without reason or explanation. The data was real, verified, cross-checked, archived, but conclusions never formed. Every explanation stopped just short of certainty. Natural models felt incomplete. Artificial ones felt unprovable. The unknown stayed intact, and that may have been the most honest outcome possible, because sometimes the universe does not offer closure. It offers contrast. 3I/Atlas didn't leave behind wreckage. It didn't leave behind answers. It left behind perspective. As the object exited the inner system, it became harder to care about what it was. That question had exhausted itself. The more difficult question: what had changed in us? Before 3I/Atlas, the universe felt predictable. But strange, yes, but understandable, governed by rules we trusted, even if we hadn't learned them all yet. After 3I/Atlas, something subtle shifted. Not panic, not fear, awareness. The awareness that behavior can exist without explanation, that systems can function without announcing purpose, that intelligence, if it exists, does not owe us clarity. Scientists returned to their work. New objects were discovered, new anomalies logged, new mysteries emerged. But this one stayed different, because it didn't resolve. It simply passed, like a thought you can't finish. Some tried to reduce it to a footnote. A strange case, an outlier, an object we'll understand better someday. Maybe that's true. Maybe future technology will reveal what we couldn't see. Maybe the mystery will collapse into simplicity. But even if it does, the moment will still matter. Because for a brief window in time, humanity stood face to face with uncertainty and didn't look away. We didn't get an answer. We got a question powerful enough to last. Did we witness a passing object? Or did we witness the moment our understanding quietly shifted forever? That question isn't about 3I/Atlas anymore. It's about how we define knowledge. For centuries, discovery has followed a familiar arc. Observe, measure, explain. This time, the arc bent. We observed. We measured. And then we stopped. Not because we failed, but because explanation didn't arrive. That doesn't happen often. And when it does, it leaves a mark. The sky looks the same as it always has. Stars burn, planets orbit, light travels. Nothing visible changed, but something internal did. A small crack formed in the idea that everything strange must eventually become familiar, that every mystery waits patiently to be solved. Some don't. Some simply move on, carrying their truth with them. 3I/Atlas carried its origin beyond reach, beyond instruments, beyond models, beyond debate. And that's okay, because the goal of science isn't certainty, it's honesty. And the honest answer here is simple. We don't know. We may never know. And that realization doesn't weaken understanding. It deepens it. Because it reminds us that the universe is not built for our comfort. It doesn't slow down to be explained. It doesn't reveal itself on demand. It just is. The object is gone now, fading into the dark between stars, where silence is normal, where time stretches beyond meaning, where questions don't echo back. Somewhere out there, 3I/Atlas continues whatever it was always doing, passing systems, enduring extremes, keeping its consistency, or maybe dissolving. We don't know. And that unknown remains intact, unbroken by observation, unchanged by attention, as it should be. Because not every encounter is meant to teach us what something is. Some encounters teach us where we stand, small, curious, limited, yet capable of noticing, capable of questioning, capable of sitting with uncertainty without turning away. That may be the real legacy of 3I/Atlas. Not proof of artificial origin, not confirmation of intelligence, but a quiet reminder that the universe is still larger than our explanations, still deeper than our definitions, still able to surprise us without ever explaining why. We didn't receive a message. We didn't decode a signal. We didn't uncover a builder. But we did experience a shift, a subtle one, the kind that doesn't announce itself but stays, the kind that changes how you look up at night, even years later. Wondering, not what's out there, but how much of it can pass us by, without ever needing us to understand. And maybe that's the unanswered truth. That discovery isn't always about adding knowledge. Sometimes it's about learning where knowledge ends, and standing there, quietly, watching the darkness move and realizing the universe doesn't have to explain itself to be real. It doesn't have to speak to be meaningful, and it doesn't have to stop just because we're left behind with questions. 3I/Atlas didn't change the sky. It changed the space between certainty and humility. And once that space opens, it never fully closes again. So the object is gone. The data remains. The answers don't. And somewhere in that unresolved space, a new understanding has begun. Not loud, not dramatic, just a quiet shift, one that may shape how we listen the next time something strange passes through our sky, and leaves us alone with nothing but questions and the courage to admit that sometimes the most honest ending is no ending at all.